So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is a very one must code this side. So today's question is kth missing positive number. Very interesting question. Just stay with me. This question is will actually give you chills. Okay, so what does it say? It says that write the counting. Okay, I know about that. So what is the counting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? Now, it says that I have given some specific numbers which are mentioned in the array, that is 2, 4, 9, 10. Circle them out, 2, 4, 9, 10, and remove them from the counting. Right? And now tell me the fifth number. After removing the circled elements, now tell me the fifth number. So you will say, this is my first number, second number, third number, fourth number, fifth number. So you will say my answer will be 7. My answer will be 7. That is all what you have to do. You have to write the counting, you have to remove the elements mentioned in the array, and then you have to return the fifth number. Fifth number after removing these elements. As simple as that. Now you will say, what if it has asked eighth number? So you will say, okay, this is what my fifth number, sixth, seventh, eighth. Okay, then you will say my answer is 12. This is the question that is asking you. Now, this question is interesting because the way we are going to solve it is actually very interesting, right? What is the brute force, by the way? What is the brute force? Let me mention. Let us go from the brute, then better, than optimal. So brute force, right? You have the array 2, 4, 9, 10, and you want fifth number, right? Brute force always says what has been given to you in question, do that. Okay, so I have this in an array. What will I do? I will create a map. It is also mentioned that the elements are distinct positive, right? I will create a map. So 2 is occurring one time, 4 is occurring one time, 9 is occurring one time, 10 is occurring one time, right? Now I will start from 1. I start from 1, right? Now I start from 1. I see map does not contain 1. Okay, so I will say count equals to, it was starting from 0 because 1 is not present in the map, so increment your count. It goes to 1, go to 2, 2 is present, go to 3, 3 is not present, increment it. Go to 4, 4 is present, don't increment it. Go to 5, 5 is not present, increment it. Go to 6, not present, increment it. 7, not present, increment it. Now count equals to 5, that is the number in hand, that is this 7 is actually the number, 7 is actually the number we are looking for, that is our answer. Right? What is the time complexity? First you need to insert them, so O of n for this, and then O of answer, right? So it is all in all O of answer, right? O of n, I can say linear time complexity and linear space complexity. This is my time complexity, this is my space complexity, right? Okay, brute is done, but we not need a brute force. We know O of n way too much. Let us try to decrease it. So efficient. Okay, so our array is 2, 4, 9, 10, and we need to find the fifth number. Now, don't forget about these elements. Tell me, if you have an empty array, that means you need to write the counting 1, 2, 3, 4, 5, 6, 7, 8. Because the array is empty, you will not have to remove anything. And now the fifth number will always be 5. That means you are saying that the least number, if this value is k, then least number is k. It cannot go below k. Right? And now if I say that this array contains first n natural number, that is 1, 2, 3, 1, 2, 3, then you will say remove this 1, remove this 2, remove this 3, right? And now you will say, if I start counting now, so 4, 5, 6, 7, 8, 8 will be my number, right? That is a maximum number. Can be. If you see, maximum number occurs in which case? When the array contains all the natural numbers, that is 1, 2, 3. That is, my maximum number can go for k plus n, where n is the size of array. Size of array. Are you able to understand how? So if I remove these three, then only I can reach 8, right? Then only I can reach 8. Obviously, I can reach 8 if I remove 5 also instead of 3. Then also I will reach it. But 3, like I cannot reach further than 8. In any case, if I choose 3 numbers to be removed, I cannot reach farther than 8, right? If I choose 3 numbers to remove, 8 is maximum I can reach. So that is, I say maximum number is k plus n. Maximum number is k plus n. Okay. Now can I draw any inference? Can I draw any inference? My array given to me was 2, 4, 9, 10. I say my lowest value is k. Highest value is k plus n, where n is my size of array. I come to 2. I come to 2. Right? Should 2 be mentioned here? Should 2 be mentioned here? What is actually happening is, it is actually saying that this array represents counting. This array represents counting. Right? But from this counting, some numbers are missing. Some natural numbers are missing. This is a sorted array. You have to tell the kth missing number. Kth missing number. So I guess you are understanding what is actually happening. So you have to think of this array as an array of counting where some numbers are missing. You have to tell the kth missing number. So ideally, one should be at the first position because that is the lowest number. One should be here, but one is not here. What is here? 2. Let me write down the indexes also. 0, 1, 2, 3. Right? 0, 1, 2, 3. K equals to 5. I need the fifth missing number. Right? Fifth missing number. I come to first position. I say 2. 2 should not be here. 2 should not be here. What should be here? It should be 1. How can I say that it should be 1 here? Because 0 is here. Index 0 should always contain 1. That is, 2 should not be here. Right? 1 should be here. Can I say that 2 is my answer here? No, 2 is not the answer. We know the answer. What is the answer? We have our answer in our hand, 7. Beforehand only. We will just check our algorithm is fitting or not. Our algorithm is fitting or not. Now, I say 5 plus 0 equals to 5. That is 5 plus index. If this value is less than your ARR index, then your answer is equals to k plus index. This is my hypothesis, right? Let us test it how. Let us test it how. Okay, we are coming at 2. 2 and 5 plus 0. That means 2 and 5. 2 is not greater. 2 is not greater than 5. 2 is not greater than 5. We come here. 4 is not greater than 5 plus 1. 9 is not greater than 5 plus 2. Oh, sorry, 9 is greater than 5 plus 2. That means my answer will be 7. And we observe my answer is 7. How is that happening? Let us see. How is that happening? Let us see. So I will have to write something here. Okay. So my array given to me is 2, 4. Let me create some space. 2, 4, 9, 10. These are the numbers given to me in the right. In the white line. 1, 2, 3, 4, 5, 6, 7, 8. These are the numbers not given to me. 11, 12 and beyond, right? Okay. Now, indexes are 0, 1, 2, 3. Indexes are 0, 1, 2, 3. Right? Please be very much clear. Please be very much clear. This is the only concept you need to understand. Okay. I come here. I come to this index. Right? I say that the ideal number here should be 1. I say ideal number at index 1 should be 2. I say ideal number index 2 should be 3. I say ideal index at index 3 should be 4. Right? That is clear. How am I saying it? Because if I say an array which does not contain any missing numbers, that will be 1, 2, 3, 4. Index is 0, 1, 2, 3. So 0 contains 1, 1 contains 2, 2 contains 3, 3 contains 4. Right? Okay. Okay. Ideally, this should contain 1, this should contain 2, this should contain 3, this should contain 4. But they contain 2, 4, 9, 10. Okay. Now, if I say I have k equals to 5 in my hand, k equals to 5 in my hand. If I say k plus 0, that is sorry, k plus index. k plus index, right? K plus index, that is 5 plus 0 in the first case, 5 plus 1 in the second case, 5 plus 2 in the third case, 5 plus 3 in the fourth case. That is 5, 6, 7, 8. 5, 6, 7, 8. That means if I'm writing this 5 plus 0 equals to 5, what I'm trying to say is if this value is actually exceeding the value present here, that is 2, is actually exceeding 4, is less than 2, is less than 4, is less than 9, is less than 10, then what is actually happening? What is actually happening? That means this value has left 5 values in between. I don't know where they have missed, but 10 means that 5 values have been missed. 10 means 10, because 10 is greater than 8, that means 5 values have been missed. 9 greater than 7 means 5 values have been missed up till we reach 9. Up till we reach 9. Similarly, 4 is not greater than 6. That means 5 values have not been left. See, what I'm trying to say is 1, 2, 3, 4 is ideal. 2, 4, 9, 10 given to us. Right? What does it mean? What does it mean? Because it is present at index 0, difference is 1. Because present at 1, difference is 2. 9 minus 3, difference is 3, 6. 10 minus 4, difference is 6. This means 2 numbers have been left. This means 6 numbers have been left. This means 6 numbers have been left before it. One number have been left before it. You can see one number have been left. You can see 3 is actually left leaving here. That means 2, 5, 6, 7. Now 1, 2, 3, 4, 5. 6 numbers are like being left here, right? 8 also, and 9, 10. You can see 1, 2, 3, 4, 5, 6, 7, 8. 6 numbers are leaving here, right? Now, as soon as it exceeds 5 plus k, 5 plus index, k plus index, that means it exceeds, that means k numbers have been left out. K numbers have been left out. As we can see, 6 numbers have been left out, which is greater than 5. 6 is greater than 5, right? 6 numbers have been left out. That means at index, what is the index? Index is 2. At this index 5 numbers have been left out. So what is my answer gonna be? Index plus 5, which is equals to 7. Why? Why? Index plus 5, why? Because this index states that the number here should be 3, but the number is 9. So I need to add numbers. On index 2, 3 should be present. But what is present? 9. So I say that 5 numbers have been missed. Actually 6 numbers have been missed, but I need to travel 5. So 2 plus 5 will actually give me 7, which is actually the fifth number. That is just a simple concept. So what is actually happening? We are traversing the whole array and we're just checking for ARRI is greater than is greater than k plus index. Wherever this happens, return k plus index. That is what we are doing. Okay, let me write it again. So 2, 4, 9, 10, right? Start traveling from here, start traveling from left to right. If ARRI is greater than k plus I, that is a plus index, return k plus I. As simple as that. So what is actually happening? We are finding minimum I for which ARRI is greater than k plus I. We are finding minimum I for which ARRI is greater than k plus I. That's all. So, finding minimum I. If you remember from the last 2 days, we are doing some work. Now, the question clearly states the array is sorted and we need to find something. So this gives me a ton of binary search. I need to find the minimum. That means I need to minimize my answer. What will I do? Simple. I need to find index I, which is giving this condition. So what will happen? I will say my result equals to, what is my maximum result can be? It will be n plus k, where n is the size of array. Low equal to 0, lowest index, high equals to n minus 1. while low is less than equals to high, calculate your mid, which will be equal to low plus high by 2. Now, if ARR of mid is actually greater than mid plus k, that means this condition is being followed. So calculate your result equals to mid, and because we need to minimize it, that means high will get down, and high will get down, that means in else condition low will get up, else low equals to mid plus 1. Else block finishes, while block finishes, return your result. So what is actually happening? This is working the same algorithm in log of n time. So I hope you're clear with it, and let us just move to the code and end the video. So here is the coding section, guys. Let us start straight away. Int n equals to array dot size. Int high equals to n minus 1. Low equals to 0. And our initial result equals to k plus n. While low is less than equals to k. Calculate your mid. So int mid equals to low plus k by 2. So if our array index is greater than mid plus k, our result is gonna be mid, and because we need to find a minimum answer, so high equals to mid minus 1, else low equals to mid plus 1. Now return your result. Let us try to compile and run it. I am pretty sure that this will work. Oh, this is not working. What is the error, guys? What is the error? Low should be less than high. Typing mistake. Sorry, guys. Let us try it now. Again an error. Again an error. Let me see what is the error. Our answer is 2. Oh, sorry. It will be result equals to mid plus k. Sorry, guys. Let us try it now. Working fine for the sample test case. Let us see for the summation test cases. A program took more time. Okay, so mid is low plus high by 2. I have written k instead of higher many times. It should work fine now. Working fine for sample test case. Let us see what the hidden test cases. Okay, it is running and getting accepted. So thank you for the patience, and thank you. Have a nice day. We'll meet again tomorrow. Till then, stay tuned and please make sure to subscribe to the channel.